Hi guys and ladies, welcome back to another exciting episode. My name is Disema Matieti and welcome to episode number 21. In this episode, we're going to be discussing the different database types, and doing so, we're going to tell you which ones are SQL and which ones are NoSQL. SQL is the structured query language databases, and the NoSQL is the ones that do not perform or conform to the SQL structured query language protocol or language. And we're going to be discussing that just after our theme song. So stay tuned. I'm glad that you were able to listen from episode number 17. And if you haven't, please make sure that you go back, you listen from episode number 17. We spoke about different things, especially talking about are we ready to implement 4IR within small businesses? And I'm assuming now in episode number 21, you're asking yourself, now, how do I do it? You already did the ITR model, the investment time return model. You picked up your small business that you want to go for, and you've spoken to the guys, and you know exactly what you want to do. But the problem is to say, how do I now implement the solution that I'm looking for? And now we're going to be telling you about the different database types before, so that to help you before you start to implement the database solution, so that you know which one will be the right database type that will enable the business to go forward. In so doing, I'm gonna try to give you like the characteristics of that database type, as well as the advantage and disadvantage of it. We're going to be talking about six of those. First one is relational database. Second one is document database. Third one is graph database. The fourth one is analytical databases. The fifth one is the column family database. And the last one that we're going to be talking about is the key value database. Six of those that will help you to understand. And as well as we go along, I'm going to give you an indication to say which of these are conform to the structured query language and which are not structured query language friendly databases. And you might be asking yourself, why would I implement a NoSQL database? Just stay tuned. I will be able to answer all of that. Let's start with the one that we all know. It's called the relational database. This is the one that we all are quite familiar about. It's where you create tables, and the tables, can be joined and all of that. This type of database, which is normally referred to as a SQL database, SQL database, structured query language database, came into play about 1970. So it's been around for decades. So almost all data engineers, data analysts, data specialists, they are quite familiar with this one. Why? Because the characteristics includes it's a structured data. So it has well-defined tables with specific data types. I mean, we've spoken about that even in episode number 20. Each column, it ensures that there's consistency within the organization. It has the schema, a relational database. It enforces a fixed schema. It has ACID compliance. ACID stands for automaticity, consistency, isolation, and durability. It also has some data integrity, meaning that relational databases can maintain data integrity by enforcing constraints such as uniqueness, primary key, foreign key data, all of those things. And the nice part about it is you can actually run SQL queries on it so that you can manipulate the data because it allows for that. So that's just the characteristics of a relational database. The advantages of it is the following. The first one is it's a mature technology. It has been around from 1970. I mean, right now, I mean, we're in the 2220 something. You can just imagine a lot of people know about this. It's been over 50 years already. It has data integrity because it enforces data consistency throughout the predefined relationships to say this table has got a relationship with this table because you already have those predefined relationships. It has some data integrity that if I wrote December Matsietsi here, it's 001. When I query 001, it will bring December Matsietsi. It has data relationships. As I've managed, you are able to join the tables. But not everything else is perfect with relational database. The disadvantage includes the following. When you scale it, you get challenges because it goes, one after the other. The tables go down. When you scale it, it might start to become slow. It might not be able to handle that large data set or high velocity data set. So if it becomes too big, it becomes slow. If you query in too much, it becomes slow. So that's the problem with it. You might also have some schema challenges. Modifying the schema of relational databases is sometimes complex and requires careful planning and avoiding disruption. So before you move things around, you have to make sure that people are out of the database. And even after moving things around, changing the schema, I mean, things might just fall off the wheel. Performance, like we said, can also be impacted. So this one is quite nice. Because most financial systems, whether it's a customer relationship management or CRM systems, even the enterprise resource planning or ERP systems are somehow using this one, relational database. So you can imagine this is why most organizations are looking for somebody else who knows relational databases. But here's what I'm going to say. It is not the only type of database that is there. Let's jump to the second one. The second database type is called document databases. Document database. These are NoSQL, no SQL database type. So the document database is the ones that you would find like the Java script object notation or the JSON. When you're playing around with your application, you right click, you see your JSON file, and you ask yourself, why is this looking funny? It's that type of database. The other one that's there is the binary JSON, JSON. So you might find weird if you go into your application data itself, you right click, you open, you find all these weird JSON or JSON files. It's that document database. The characteristics of a document database is it's flexible schema. So the schema is not as fixed as it was in relational database. It's quite flexible. So each document, like I said, in every application, it will have a document there. So you don't put them together in the computer repository. It can sit wherever you have. So each document can have its structure. So you can define your own structure and fields, and can be added or removed as needed without affecting other documents. So when you have one application, the JSON, you can move them without affecting others. But with a relational one, when you take out one document, you have to go to the hash table or wherever and remove it there too. So it's this one is quite flexible depending on what you want to do. Nice part about it, you don't have to join anything. Unlike relational database that you have to say one table joining with another. Scalability is much better. You can just see every application, you can just create another file, JSON file or whatever, BSON file. Semi-structured data, it's also one of its key characteristics. So documents are suitable for storing semi-structured data and unstructured data, which it gives it much better advantage compared to relational databases. Because relational databases, I mean, you already say I need a name here, I need a surname here, so it's structured data. This one you can store as you feel like it. If you wanna store Mike, you can say Mike or name, whatever. You store data whichever way. It's flexible. And it allows for API based queries. So if you are going to be sending APIs through one app to another, you can actually use document databases to send data within those. Advantages, like you might have heard me say, flexible schema or schema's flexibility, performance is much better, and there's a variety of data because they are suitable for applications with varied data types, formats, and structured. Okay, not everything else is well with document databases. The disadvantages of that, if you want to query, it can require complex queries, because some advanced queries might need to be involved if you want to pull out the data because it's not structured. So you might struggle a little bit if you want to query it from different applications. You want to bring all of that together because it doesn't follow the same format or same structure. Data consistency, especially ensuring consistency across different documents with relationships, can be extremely challenging. So it might also affect your setup, your distributed setup, meant to say. Your ACID transactions might also struggle. They might not provide the same level of ACID compliance as relational databases. Are you scared as yet? Don't be scared. Document database is not the only one. The third one, we're looking at the graph database. Graph database, of course, because you think about a graph, it's a NoSQL, no SQL database. So a graph database, it's ideal to actually manage data in a form of nodes or edges. This is where you are doing graphical representation of data. The one that I could think about is when you are doing like location or stuff like that. I think you might have want to store it in graph databases. The characteristics of it is it has a graph structure, and because data is stored in nodes, which is equivalent to entities instead of entities, what we know as a column in a relational database. But in this case, it's called a node, and then it's called another one is edges. Instead of we calling it a row, edges are the relationships. So you have a node, which is an entity, and a edge is the relationship between a node and the other one. So you store December is here, and his relationship with you is whatever you write the relationship here. And that's how you edges and nodes. It has a relationship focus. It's relationship focused, as I've just demonstrated now. It has graph algorithm, and the schema of it, just like the document one, is quite flexible, and it allows for complex queries. So it excels in answering complex queries involving multiple level of relationships. So think about it this way: when you're doing graphical data, is that one that says how many relationships um, do I need to connect with you? So it's easy. You can go into LinkedIn and you can say, December is here. I have to jump so many nodes, or I have to have so many edges to get to this person. We can think of it that way as a graph database. Or maybe you might have another example. Advantages of it: relationship analysis, like what we see nowadays in LinkedIn, that it can always give you instantly to say, how many degrees are you from that person? So you'll see president of a country and it will tell you you are 6 degrees away from that person. And when you connect with another person, it says you are now 4 degrees away from that person. You're like, whoa, what just happened? But it will show you to say the quickest route to connect to that person is through this. Flexible querying, graph data allow for complex, recursive, and pattern-based querying that can uncover insights that might be difficult to discover using other database types. Like what we said, you cannot. Well, it's not easy to discover how many degrees am I away from somebody else if I'm using relational databases. I mean, we have to go and then rewrite and rewrite and rewrite, or make a very, very difficult data science script to make that. But if you store in graph database, you might not need to. And for that, the performance is much better to understand how many degrees am I from a person if I'm using this one, if I'm using graph database compared to if I'm using any other database. Okay. The disadvantages of that is that performance complexity, where extreme large graphs with many relationships can lead to performance challenges requiring careful consideration of indexing and optimization strategies. As much as we can see how many degrees you are from somebody in LinkedIn, that's why LinkedIn doesn't give you the access of how many degrees away from somebody you are from for everybody in the world. It doesn't give you all of that thing in one go. you have to go one person at a time so that it's a simple, easy query. If I say everybody in the world, you can imagine the performance issues on there. Data complexity, while powerful craft databases might not be the best fit for all data types or application, especially those that don't heavily rely on relationships. It's also some other things. Complexity might just be another issue. But don't you worry, this is not just the three ones that we're gonna be talking about. There's still the one that we are so used to nowadays. It's called the online analytical databases, or OLAP analytical databases, or you can call it the online analytical processing database. This one is a SQL one because you can query it in SQL. It has been made popular by nowadays when Power BI come through. It allowed Power Query. So Power Query is the online analytical processing database. Besides that, we used to do it manually on SQL Server Manager, and you would call it a cube. And we've been calling it a cube because of legacy softwares like what SQL used to call it. But the proper word for it's analytical database, or OLAP, which is the online analytical processing database. Okay, the characteristics of that, as you have known, if you're working with Power Query, you'll realize that it has the multi-dimensional data. It's a multi-dimensional data model. You have a data model, you can see the data on different angles, not just columns. And because it already connects the databases together and it creates a huge data model. So when you are joining, you are straining the performance on relationship when you are using relational database. But when you are joining and you are creating an analytical tool, the performance becomes much better. So that's what you're getting with with your multidimensional, with your OLAP, with this multidimensional characteristics, and it also helps you with aggregations and stuff like that. Okay. Another one, it allows with aggregation and summarization, as we have seen most of the time when you pull in a column from this cubes, it already calculates what is the total there. When you pull in another dimension, it already calculates for you and gives you the accurate number. And it can work for complex queries, which might have required too many joins when you're dealing with relational database. This one will be able to help you accordingly, and it's best for historical data. So when you want to query something else from 7 years, 20 years, 100 years ago, OLAPs are the best ones because, as you are saying, from this date to that date, it's like you're already writing a custom SQL query. So it works much better. And other people love this OLAP data types for data warehousing, because now I can give you access to one model, one cube model, and you can be able to do whatever you want to do in that space. Okay. Advantages of it, like we said, high performance, aggregation capability, making it you can do your own summing, summarizing, aggregating, making it easier to generate more and more reports. Business intelligence, like we said with Power BI, and probably also with Tableau, and large scale data analysis. Unlike your normal relational, the OLAP can actually help you with large scale. But not everything else is good with OLAP or a cube. There are a few disadvantages that we can actually look at. First one is data freshness. Because of how it's structured, you might find out that it doesn't give you live data. It might have to take data and then do the linking, and once it's done with the cube, then make the cube available. So at that time we might have missed on fresh data. So on our side, we would run the refreshing of the cube overnight. So daily, on that day, transactions we would have missed from the cube, and it will only refresh the following day. So that data freshness. Ooh. Another thing is it's quite complex to set it up. So you need a highly skilled person to actually help you set up a cube, compared to running a standard relational database query. So a OLAP is a little bit, complex, and you have limited transactional support. So meaning that it is optimized for querying and analyzing, but they might not offer the same level of transactional support as traditional relational databases. So it might stop at one point. So, hey, I'm running out of RAM. And when it says that, you just feel like you want to throw your computer. But that just is disadvantages. But if you know that you're going to be querying something small and you're not going to be querying a million rows, OLAP works quite well. If you query too much data, you are just killing the RAM and it doesn't work. Okay. Don't worry about that one. We're moving over to the fifth one, which is the column family database. The column family database. If you want to remember this, remember it this way. The relational database, you have columns, but you store data in rows. So you store December, Petrus, Dibuseng, you store names going by rows. Column database stores names by columns. So you have December, Dibuseng, Petrus, Mang, Luana, going that way. So I know you're asking yourself, so ain't you gonna run out of columns? It's because you are used to Microsoft Excel. So remember, Microsoft Excel only allows for lesser columns than the rows. So you can say Microsoft Excel is both relational and column-based, can create column-based database. But in this one, in a column-based family database, you are able to use all your rows, and it can handle large amount of data compared to the relational database, compared to if you store this way. If you store by a column, you can actually get large amount of data. Why? Because when your column is finished, you can jump into another distributed computer and then continue storing by columns. Okay. So the characteristics is a column storage. It has distributed architecture, hence why I said many column-friendly databases are designed for horizontal scalability, meaning they can distribute data across multiple servers to handle large data sets and high-velocity data. They are scalability and performance. It's also another thing you can say that. Schema flexibility instead of this one that goes by row because you're stuck by that column. Column one is flexible. You can actually work out, however one that you want to do. And in addition, the deletion, allowing data models to evolve. You can delete, you can add, you can do all of those things. So you can evolve accordingly. Nice things about it is also compression and encoding. Due to their columnar storage, these databases can implement compression and encoding techniques that reduces the storage capacity that's needed. So the advantages of it, as you may look at it, is efficient storage, scalability, compression of storage, analytical, and aggregation. The disadvantage on the other side, complex queries becomes difficult because you're not dealing with columns, not with rows. Limited transactional support, data relationships might also be, an issue that you're dealing with. So that's just the problem with the common family one, and it's no SQL because you're doing queries on a database that goes this way instead of going this way. The last one that we're looking at, number 6, is the key value database. So the key value database, it assigns a key to every thing that you are storing. So if you're storing December Matsietsi, there's a key to it to access December Matsietsi. So you can see you cannot just use it for everything else like you do with a relational database. This is for specific things that you want to store. So the characteristics of it is very simple, simplicity, high performance, schema flexibility because you can store it in a way, it just a value and a key to that value, scalability, and it also helps with catching because you can be able to do all of those things. So in terms of the speed, there's flexibility and scalability. I think it has a much better advantage compared to some other type of databases, especially because it stores and retrieves data using simple key value pair model. So in that pair model, each piece of data is associated with a unique key, and it allows for that efficiency and that quick data retrieval. The disadvantages of this one is that is limited querying. So we can store, but it's quite limited to query this. This is because are not well suited for complex queries and aggregation that involve multiple keys and multiple values. So for that, that's why we can't query it. And it also have lack of relationship because there is no foreign key or whatever. It just a key to say the name December has got a key to it. So every time you can just store the keys somewhere else, but if you have the key, you get the name December. Think of it as doors and keys. So you got multiple doors in a suburb or in an estate, but those doors are not related to each other. If you have the key, you can unlock the door, but if you don't know which door the key is gonna open, I mean, you are stuck. So I know what you're thinking about. This is quite nice for security. If you are storing somebody's security and you want to store a security key, this is the one that you use. Yes, your password uses this type of uh, database. So you would have your key, your password, it unlocks whatever comes inside, whatever secrets that you have stored. So I'm just assuming and I'm hoping that what we've covered today helps you decide to say, okay, I've went to a small business. I'm saying actually SMME in this case, because most big businesses or big organizations, they already decided what database will be good for them. But if you're opening up on a small business, you can always have that availability to say, oh, hang on a second, what you are selling here, I think it will be captured correctly using a column database, or it might be captured perfectly using a key value database instead of a column family. Or you know what, I can see that you're having different tables uh, and they might have to follow a certain standardization method. So for this case, we're going to have to do a relational database. Thanks for joining us in this episode 21. Let's chat again in episode 22. Stay blessed.